Hi and welcome to this new video where I'm going to show you how to go from nothing to create a simple robot arm and give it some materials, give it some joints and export it to ROS2 so that we have a package that we can use in Rviz and Gazebo. So let's get started. I've already done it, but I'm going to go step by step showing you how you can do it. This is not a tutorial on Fusion360, but at least you have some starting point on how to do it for yourself. The first thing is you have to create a drawing, and it works like SolidWorks on shape. And this is quite simple. Just put the vision, the plane that you want, and then select, create a draft and select the plane that you want to draw on top. And then you have the tools to select and draw whatever you want. In this case, we're going to draw a circle. Once you have the draft, which you should have something like this, like a circle, now what we're going to do is extrude it. In this case, we're going to do just a cylinder. So it's really simple. Just go to extrude, select the face, in this case here, and extrude like that. Boom, that's it. Accept, and you will have a part that it will be something like this. There you go. Very simple. Now, what we want to do is a 90-degree turn and a very special shape like this one, okay? We want this shape. How can we do that shape? The only thing that we have to do is draw, you can see, a curve. We draw a curve that we drew it just doing a sketch in this plane. If we press here, let me just like that, and this plane, and with that one we can draw this line, and you can draw them just by the following. Just let me show you another example. Let me draw a line. I would draw this line, then this line, and something like that. Okay, that's it, and then accept. Once you have it, then we click on this and we select the lines holding shift, and we can move it until it gets that exact line. Okay, very simple. So how is this done? Once you have that draft, which is this line here, let me just go here. Okay, we have this line. The only thing that you have to do is go to create, and there's one option that says in this case barrido in Spanish, but it's this drawing of a blue shape that follows a line essentially. So you go here, you select the shape and the line. In this case the shape is the face, the top face of the other element that we just did. And then we select the line, in this case, this line. That's it. And that's how we have been building the rest of the arm. So you can see that we generated this line and we do this same exact thing, another line here, and then we do the exact same thing with then another draft with, you guessed it, another line, and we do another shape, another line, and finally this shape. That's it. That's what we did. And now we have, at the end, you should have 4 bodies with different names. And it's very important, this is important, that when you create the model, let me show you here. Let's go, for example, this last one, okay? When we go here and we create the part, it's absolutely essential that you do the following. So if you select this one and we select this face here, and then we select the path that has to be followed, okay, it's absolutely essential that you don't select as operation, you have to select new body. Okay, new body. It's this shape like cylinder with a star here. If you don't do that, it will generate a single monolithic element body that we don't want to. We want different bodies. Okay, that's how we should do it. At the end, you should have something similar to this. Okay. All right. So now that we have our model done, the first thing that we need in order to be able to convert this to a URDF is something very simple, which is we need to create an assembly, which means that each of these parts has to be a separate element and has to be connected to the others through joints. For that, there's this fantastic element which is called union, joints. And it says that we need to have components. We have to convert all our bodies that we generated in the previous step to components. That's very simple because the only thing that we have to do is click on the bodies folder and click on create components from bodies. And there we have it. Now we have all these bodies that were before. Now we have them as components. This way, we are able now to use the joint functionality. Before doing that, let's add some colors so that it's easier for us to know when one element, when one component starts, the other one ends. For that, what we have to do is select the body and in the body, select the aspect. In this case, we are going to select paint and smooth. You can download any of these materials. I'm just going to select them like that. So red for the first one, green for this second element, then blue for this third one, then yellow for this fourth one, and a white one that let's do it white like that. We can download it and then click on here. Perfect. We can close it and save. To create the joints, we have to select this joint element, and here we select first always the child and after the parent link or element in this case. For that, what I like to do is this base link, I'm going to hide it, and then we are able to select the center like that. There we go. And now we're going to put it back again and get the limb one, this out, and we select the center. That's it. Now we have to select the movement. Let's visualize the limb one and the kind of movement. In this case, we're going to select revolution. Perfect. It's revolving around the axis that we wanted. Perfect. We click on accept. And you should see here in unions, there's a revolution here. We're going to rename it to base link to limb 1. Or better, limb 1 to base link. There we go. Limb 1 to base link, and we're going to say always the child and the parent, the child and the parent. Yeah, that way when we convert it to URDF Chakro, it will be very clear which joint it is. Otherwise, it's a bit more confusing. Let's do the same thing, but for the others. We go in here and we select the limb 1 like that. We hide it. Then we select the child, in this case, limb 2 and limb 1 Again, we select this, we put it like that, and we check that it's revolving around the axis that it should, in this case, perfect. We're not going to put limits because we don't need them, actually. And afterwards, when we do the conversion to the chakra and we use it in Gazebo, we'll set the limits in the control system. So it's not big a deal. And that way we have freedom for now. But you could select the limits of movement, okay, in case that your robot has those limits. There we go. Now, let's rename this one again. Limb 2 to limb 1. And again, let's go to hide limb 2, go to joints, select the center, and now limb 3, we hide it and we unhide limb 2, and we select this. Now let's see the movement, how it works. There we go. Fantastic. We accept and we rename it. Limb 3 to limb 2. There we go. And finally, we select this guy here. Let's have a look. Limb 3. We hide it and we do union, select this center, and now limb 3, limb 4, and we select this guy here. We see the movement, we hide this, check, fantastic, marvelous. There we go. And finally, we rename it. Limb 4 to limb 3. And there you have it. Now we have all the joints necessary for our robot. In your case, it will be totally different, but this is how you set joints in Fusion360 so that this works. Let's save. The next step is importing the plugin that makes all the magic happen. For that, you have to go to this website. You have two options, depending on if you use ROS1, ROS2. They are basically the same. I will use the ROS2 version, and for that, you just have to download it like a zip file and unzip it. If you unzip it, you'll get something similar to this. So you have this Fusion2 URDF. In this case, this one's the one, ROS2. And there's this folder that has this script, and this script is the one that makes everything happen. How can we make Fusion360 have this plugin? There's various methods, but the method that worked for me, at least, was to copy this folder, the folder URDF exporter ROS2, to the path where you have installed Fusion360. In my case, it was this path that I have here, which is app data roaming Autodesk Fusion360 API. And inside that one, there's a folder that it's called scripts. You can see here, scripts. And here I just copy pasted the folder that has the script that will make the magic happen. If you do that, then when you close Fusion360 and you open it again, you can go to utilities, and in complements, you have here, it should appear URDF exporter ROS2. That's it. So how does this work? Just click on it and run it, execute. It will ask you, where do you want to export? In this case, we're going to create a new folder that it's called exports ROS2, and we select that folder. And that's it. It should had successfully generated a file. Let's have a look. If we go here to the, in this case, have them here, exports ROS2, we have this new folder which is called ArmBot ROS2 description, and inside it we have a URDF. And if we go here and we open it with code, for example, we can have a look that effectively it has added all the links, all the joints, and in this case they are continuous. That's what I told you, that we are considering these joints continuous, but if you set some limits, then it will be revolute. In this case, it's more than enough like that. And that's it. That's how you have the ROS2 URDF files generated from Fusion. Right, so now what we have to do is just one step, which is we go to our ROS2 workspace in our local computer, or in this case, I'm showing you this in a project in the construct. It will be exactly the same in your local computer. You have in the video description the link to this same project where you have everything solved and plug and play with a notebook explaining all the steps more or less that we've been doing till now. Okay. The thing that you have to do is we have to go to our ROS2 workspace and upload our file. In this case, I've already done it. And this is our package that was generated through the URDF exporter for Fusion360 for ROS2. The same process would be for ROS1. And it's very simple because it's already done for you. So we have two main scripts that we're going to launch. One is for displaying the URDF. So that means that the chakra will be published through the robot state publisher, and through the joint states and joint state publisher GUI, we'll be able to see how this model works and if it's correctly generated in Rviz. So let's have a look. This is the command. Let's have a look. We open a terminal. Doesn't really matter which one. Let's look. There you go. Obviously, you'll have to compile your ROS2 workspace using a Qualcomm build. We won't go into details there. And here you have it. So we have our model that was generated in Fusion360 and with the joints that we defined. There you go. Working perfectly. So this means that you will be able to use this model for visualizing the state of the robot. If you have this robot physically and publishing joint states in ROS2, you'll be able to visualize exactly the configuration of your robot through Rviz. That's one thing. Then the other thing is Gazebo. So we can have a look how it's working in Gazebo. It's a very good starting point to have a simulation, at least the basics working. There you go. So we have our arm. It doesn't have control or any means of being able to use it in any way. And you can see that the inertias are correctly calculated, which is a pain, especially with very complex shapes you normally have to simplify in some way. In this case, we have them already done for you. And also collisions, which are basically using the meshes that were generated. In this case, we can see here in meshes that they were generated through STLs. Yeah. And if we hit play, we can see that our robot is just a limp. It's with some joints, but it doesn't have any control. It's not joined to the world, which with robot arms, it's very important that we place it here fixed in the world so that it doesn't move around like this. Basically that falls, but it works perfectly. So things that we need to do now, we would need to add the controls. That's one thing. We would need to put it fixed in the world so it doesn't fall. And also we need to give it some colors as we did in Fusion360 model, but that's for another video. And you may be asking, okay, Mike, how can I learn all this? How can I learn more about ROS2? Because I understood more or less what you explained, but I want to know more. You're in luck because we are opening this masterclass for robotics developer and you can enroll today. So if you're interested and want to make a career of this, you want to understand everything that there is about ROS1, ROS2, and robotics development in general, this is the masterclass for you. So what are you waiting for? So thanks a lot for watching and see you in the next video. Peace.